Welcome to Living Outside the Matrix, the podcast where we examine important issues either ignored or misrepresented by the mainstream narrative. Hi there, I'm your host, Nigel Howitt, and on the show today we're going to cut to the core of one of the most basic scientific principles. We're going to examine the idea that to be valid, a theory has to accommodate all of the facts and contradict none of them. This won't be a surprise to any of you truth seekers familiar with the scientific method. And the context tonight is we're going to examine an alternative model of our solar system, and it's one that appears to accommodate all of the evidence, the observational data as we observe the night skies, whereas the conventional model that we're all familiar with, the heliocentric model with the sun at its center, there are a number of anomalies with this model. There are a number of problems that astronomers have been baffled by for centuries and that aren't explained by this model. So joining me to discuss this fascinating topic are Simon Shack, a researcher who has written the book The TYCHOS, our geoaxial binary system. The book explains this model we shall discuss, and also an associate and colleague of his, Patrik Holmqvist, an IT specialist in Sweden who's developed a computer model of this system, which we refer to as the TYCHOSium. So first up, thank you both for joining us today, and a very warm welcome to the show.
Thank you for having us, Nigel. It's a pleasure.
Hello everyone, I'm Simon, and I'm sorry I'm not on video. I've got a problem with my camera.
Maybe we could start off, guys, with just a brief introduction. Simon, why don't you continue there and let the listeners know who you are and how you got into this?
Yes, well, I've been researching for many years. I have a forum where we do research about the various strange things in this world, the false news and the false science and many such things. And maybe I would say like 12 years ago I started looking into NASA, and there were strange things going on with NASA. So I spent some time looking at, from the moon landings to, but beyond the moon landings. I think NASA is basically a Hollywood division, but we won't discuss this now, because what I did after that was, since I became convinced that NASA do not do what they say they are doing. They are not going into space, but anyone can maybe laugh this off. And what is important now is what I did after I finished my NASA research. Because I was convinced that NASA is not going into space, that was what triggered me to look at astronomy. This was about 7 years ago. So I started looking into astronomy and reading all kinds of literature. I'm lucky enough to read in 5-6 languages. So I could read any kind of books in French, English, Swedish, and so on. So I really made a big homework first to start understanding astronomy. I'm not an astronomer, okay, but I have now come to a point where I'm very surprised at how far I've come, because I have redesigned. Well, I've actually used Tycho Brahe's solar system. Tycho Brahe he's not very well known. Everyone knows Kepler and Copernicus, but Tycho Brahe was in the 16th century the number one astronomer. I mean, he was the one who had devised a system where principally he had the Sun and Mars intersecting. Their orbits were intersecting. And he had the Earth in the middle, so you could call it a geocentric system, but it's called a tychonic system. It was valid for at least 100 years. Most of Europe followed Tycho Brahe's system. And before Galileo came around, and Copernicus, of course, and Kepler. But the Tychonian system was very much almost established in the 16th century. because it worked pretty well. But there was one thing missing. There was this. It still had problems, so that's why it was eventually discarded. So the problem that the tachonic system had was that the great observer, Danish observer Tycho Brahe, he said that the Earth was completely still. It didn't even have a rotation around its axis. Although at the end of his life, he actually accepted even the rotation, because his closest pupil, Longomontanus, came up with that idea that the Earth also rotated around its axis. And when Tycho Brahe died an untimely death at 54 years of age, Longomontanus made the testament of Tycho's work, where he had the Earth rotating on itself around its axis. Mm-hmm. So that's the basics. I mean, I've been using Tycho Brahe's system as a basis for my study.
Well, maybe we'll get into a little more of the model there, Simon. Patrik, perhaps you could just say a brief hello and give us your background, how you got into this whole thing as well.
Yeah, certainly. Hello, everyone. I live in Sweden, and a couple of years ago, 2016, I got what's sometimes called as red-pilled. I understand that a lot of things aren't what they appear, and what I woke up around. I mean, I had studied medicine for many years before that, but I could never question things that big. But what woke me up was that I understood that 9/11 couldn't have happened as it did, and that brought me to Simon's research, and because he had he had made September clues, and that made me interested in more of his research. And that eventually led me to his TYCHOS research, and what the TYCHOS does is, I mean, we have learned since first grade that the Earth orbits the Sun, but the TYCHOS challenges this idea, and that's a big question. But I realized that I had to look into this as well, because Simon has been right about a lot of other things. So I started to look into Simon's TYCHOS research. We became friends, and he gave me a draft copy of his book. And while I was reading it, I understood that I needed to understand a bit more about astronomy. It's a subject I haven't looked into. I hadn't looked into that much before, and in order to learn or understand the model, I told Simon I wanted to build. Since I'm a programmer, I wanted to build a model of the TYCHOS system, and then he said, "Well, you can help me out with the TYCHOS work instead." So this was in 2017. So I started working with Simon and made some simulations, and this eventually became the full-fledged simulator of the entire system that is called TYCHOSium. And we started it as a 2D simulator with a bird view of the system, and now it's a 3D simulator. Yeah. So that's short my story into this. So.
Great, excellent. Well, look, maybe I can offer my view of this new system, and then you two can sort of correct me if I'm wrong, and we can sort of knock it into shape for listeners and viewers, so they might be able to get their heads around it. Sure. So as we've already sort of hinted at, we're led to believe that our solar system is heliocentric, in that the sun's in the middle and all of the planets and everything spins around the sun.
No,
but
No.
Yeah. So that's the conventional way of looking at it.
The heliocentric. Yes.
So this new system, the geo-axial binary system, which we're going to call the TYCHOS, if you like, TYCHOS, is actually, it's centered on the Earth. So the Earth rotating around and actually traveling in its own orbit actually has the sun orbiting around the Earth. So that's very different for a start. And then the rest of the planets in our solar system are actually orbiting around the sun as that orbits around the Earth. And it's a binary system, you're calling it, because I understand Mars is our sun's companion with this interlocking orbits, or however you explained it, and maybe you can go into that. So that in a nutshell is what I'm understanding when I consider this TYCHOS model. Is that a fair assessment?
Sure, it's I call it a binary system because it's the most logical thing to call it. Because the most fundamental thing I want to say now, as we start, is that something people will not know, most people that have not delved into astronomy, is that in the later years we have found that almost all the stars, practically all the stars around us, at least the nearmost stars, I mean, I could say 100% of our nearmost stars are binary. What does it mean? It means that any star you see in the sky as one point always has a companion, but the companion is always very often too small to be seen with the naked eye. So what they've been discovering in later years is that, okay, let's go back to the 1980s. In the 80s, the greatest expert of binary stars, Wolf Heinz, German, he concluded that at the end of his life that at least 85% of the stars we have around us that we can see with telescopes and are binary, which means they are double. It simply means that there is a big star and a smaller star or smaller object, and they revolve around their common barycenter. So their orbits intersect. It's very simple. They intersect. They rotate around nothing, usually, these binary stars. But in our case, Earth has probably somehow been captured in the middle of this dance of the Sun and Mars. Now, the first objection people will say, oh, why would Mars be the companion of the Sun? It's such a small object. Well, one of the first things I found out at the beginning of my research 7 years ago was that Sirius, which is the brightest star we have in our skies, has a companion, which is now called Sirius B, and it's a very, very small object. Actually, Sirius B is reckoned to be as large as Earth, 11,000 kilometers in diameter, or 12,000, between 11 and 12,000. So Sirius B is extremely small. They're calling it a star still, but it's a very small object. It's as large as Earth. Secondly, I found that the proportion between Sirius A and Sirius B is practically identical to the proportion between the Sun and Mars, which is already an incredible coincidence, but that is how things are. I mean, we're talking about the diameters that astronomers have established. So we have, we can look at the Sirius system and see the big Sirius, which is absolutely the brightest star we have by far. The second one is much fainter. The Sirius system has a large object called Sirius A and a small object called Sirius B, and they are proportionally identical to the Sun and Mars.
Can I interject there, Simon? Can I ask, in the TYCHOS model, which I've looked at, the TYCHOSium, and I will refer listeners to, there'll be a link to it, obviously, in the show notes, it shows we've got the Sun in our system with Mars orbiting around it. If we look at the Sirius model, or their solar system. Does Sirius B orbit around Sirius A in the same way that Mars appears to, or are they sort of dancing with each other? Are they orbiting around each other? Is that why you call it binary? Because I must be,
yes,
I'm still...
They are doing the same exact motion. I mean, they are dancing around each other in intersecting orbits. And what's more, there was a French study made in the 90s, I think, that's the title of the study. It's a very serious academic study. It's called "Is Sirius a Triple Star?" Because they conclude at the end of their study that there is probably a third object in the Sirius system, which they call Sirius C. Mm-hmm. So we have A, B, C, but they cannot see Sirius C with a telescope. They can just assume that it's there because of the oscillations of the big star and of the Sirius A. But they conclude that, yes, probably there is a Sirius C. But if Sirius C exists, it could be the twin of Earth. Mm. So the Sirius system might be a complete photocopy, twin of our system. And another thing I found very recently is that the distance between Sirius B and A, those distances, the close, when Sirius B is closest and when it's farthest, the proportion is 1 to 7. That's the same as we have here in our system. Mars comes close to Earth at a 1 to 7 ratio, mm-hmm. And then it goes. It is very close to Earth. It's like 56 million kilometers when it's closest, and it's 400 million when it's farthest.
Quite
which is almost identical to the Sirius system.
Yeah.
But anyway, it's what I want to again really make very clear. Most of the stars are binary. Why would our sun be the only star, lonely star? Why would it be the only single star in our universe?
Well, that makes
because we're talking about that because we're talking about it's. Astronomers agree that at least 90% of the stars around us are binary. The remaining 10% might just be that they can't find the companions because they are so tiny.
Sure. Yeah. So, well, it raises a valid point. Patrik, did you want to comment on my sort of brief overview of the system before I raise a few questions? Because obviously I've got a few questions which I think other people might have as well to pose to you both. Did you want to add on?
Yeah, sure. I think what the hard thing about this topic and the main question is the magnitude of the question, because we've been in a world view or a view of the solar system for about 200 years now. That is the heliocentric model. But what is interesting when we look back into history is that for thousands and thousands of years, the view of our system has been geocentric, and I don't think that's because of religious superstition or that people were stupid before. I think it was for good reason, because the fact is that when you look at the night sky at the same time every night, you don't see the stars move. I mean, you see that they revolve during the night, but at the same time at night they're in the same position. So that made ancient astronomers and up until the 17th, 18th century conclude that the Earth doesn't move much. But the explanation now for the heliocentric model is that the Earth does move a lot. It revolves around the sun in an orbit that is 300 million kilometers wide, but we don't see this movement on the stars because they are so far away. But
so the story goes.
But when you dig down into this argument, it doesn't have much substance. And also, as Simon has just stated, and that we see in his research, is that what we see if we put forward this theory or hypothesis that Tycho Brahe was right, and except for the small motion of Earth, is that we find, in science, you mentioned science before, that a good starting point is to expect, as above, so below. Why should our system be so drastically different from other star systems that we can observe around us? And what we see when we have been starting to observe our surroundings in space is that we find a lot of binary systems.
Yeah, sure.
And that is the basis of Simon's model.
Yeah. Well, allow me to question it, because the first thing that strikes me is that, okay, if we're led to believe that the sun is the huge center of mass in our solar system, and hence with the force of gravity, we all understand, we've all been led to believe that the planets are revolving around this central mass that is the sun. So if the sun is actually revolving around the Earth, are we to consider that the Earth is the mass around which the sun is attracted? But then how do we reconcile that with the fact that the rest of the planets are actually revolving around the sun as it revolves around the Earth? So either, I don't know which one of you wants to...
That's exactly why you have to understand what binary systems are. The Sirius, even if Sirius C doesn't exist, we can see Sirius A and Sirius B revolving around each other, revolving around nothing. If Sirius C doesn't exist, they are revolving around nothing. It's a huge star. Sirius Sirius A is a huge star that has a 50-year revolution in orbit, which lasts for 50 years, and in which it crosses with Sirius B. They intersect. So that, and all the binary stars do that. It would be an absolute anomaly that our sun doesn't do that. Why would our sun be fixed in the center? There is no star that is fixed in the center of any of the system we know. Do you understand?
Yeah.
Statistically, it would be absolutely incredible to think that our sun is the only star that doesn't have a local orbit. I call it a local orbit.
Well, I get that point. Orbit? I get that point, but and I want to reaffirm. I want to reaffirm what I said at the beginning, and that there are a lot of points of evidence which this TYCHOS model explains that the heliocentric model doesn't. But the big question that I think most people will have in their minds is, can we address this issue of how might it work? Do we have to throw out a lot of our assumptions of Newtonian physics and the laws of gravitation? Yes. Do we have to suspend that? Because I'd like to stress again that this model does appear to accommodate a lot of anomalies, namely the retrograde motion of Mars, and perhaps we'll get into that in a minute. But the first thing I wanted to question is this idea we all have been led to believe. I want to stress. I'm not saying it's the way it is, but we've been led to believe that this concept of gravity, and indeed is the sun this big centre of mass that we've been led to believe, if it's made out of helium and hydrogen, how heavy is the sun? But the question is, if the sun is not a big body of the huge mass that we're led to believe, and it revolves around the Earth, how or why or is there a theory within the TYCHOS model of how the other planets might be moving around it, or do we just have to suspend our conception of gravity and the fact that all of these things are sort of eternally going around the sun?
Well, really, we don't have to suspend every theory of at the end of the day, in the TYCHOS, the sun is quite an important thing. The first thing, most people will know that what astronomers tell us is that the sun is 99% of the mass of the whole system. The sun is supposed to be 99% of the whole mass of the system. Why would this be true if the sun is made of just helium and and hydrogen? The lightest gases we know. Hydrogen and helium, they are the lightest gases we know of. Whereas Mars, for instance, is made of rock and iron. I think we all agree on that. So it wouldn't be crazy to say that the weight, if you put them on a bathroom scale, put Mars on a bathroom scale and you put the sun on the bathroom scale, maybe they weigh the same. So that would be, Newton would come back in the picture there. Because Newton said that these binary stars would have to be kind of similar weight. But you know what they say now? When they found Sirius B, it was a big problem for Newton because it was so tiny. So what they came up with, they just simply assumed that Sirius B, the little companion of Sirius A, that the gravity on Sirius B is 400,000 times bigger than the gravity on Earth. They just assumed it. Yep. They have never been, no one has been able to take Sirius B and put it on a bathroom scale.
Yeah.
So we don't know. I mean, it's just something that they came up. It's an ad hoc solution to make the Newtonian laws still stand.
So is it similarly, sorry to interrupt you there, Simon, but is it similarly an assumption that, all of these rocks basically going around the sun, it's gravity holding it all together? Is that what we're saying right at the fundamental? Do we have to question all of these Newtonian principles, I'll call them, that we're assuming are absolutely rock solid? Do we have to question those? Because it seems that we do. If again I can venture that if the empirical evidence, if you observe the evidence and the theory doesn't fit, then the theory has to be rejected. If you can bring in another theory that does fit the evidence, well then you need to give it serious consideration.
Exactly.
And this is what I'm kind of seeing. Exactly. I mean, I still don't quite understand all the finer nuances of the TYCHOS, but I'm fascinated by the idea that it actually fits the observable evidence.
Okay, so you just said it. If you can falsify a theory, then you are one step ahead. That's exactly what I do. In the beginning of my book, I show that geometrically, the Copernican system does not work because Mars reappears in front of the same stars in two different periods. So this is the thing. Mars is the only object we have around us that can return facing the same star in 707 days. And if we do this thing 7 times, 707, 707, 707, 707, 7 times, and the 8th time, it will return in front of the same star in 546 days. It's the only object in our sky that does this strange thing. Yeah. It is absolutely unexplained in the Copernican system. It has no explanation.
Okay, can I just paraphrase that just to make sure listeners understand that? So if you look up into the night sky and you through a telescope, you look at Mars and at the same time every night, you're lining Mars up with a star behind. So that exact alignment will occur every 707 days. For 7 occurrences, and then that alignment will reoccur after only 546. Is that what you're saying?
Yes.
Fantastic.
Yes. I mean, those numbers are average numbers. Yeah. It kind of changes a little bit, but average 707 and average 546. Yeah. But and that is called the empirical sidereal interval. So Mars has 2 different ESIs. Empirical sidereal intervals. The Maya people knew that. The Maya astronomers knew that. And when I found a paper which talked about the Maya knowledge, that was extremely interesting for me, because I was taking Tycho Brahe's system and trying to make it work in my mind. But now we have the Tychosium, thanks to Patrik. And can you imagine the day when I tested the Tychosium to see if those 707 periods occurred, and then the 8th one was 546? Can you imagine when I saw this happen in front of my eyes?
Yeah.
The Tychosium shows it. It proves it. It's really game over, because the Tychosium is the only system that shows it, because Mars comes back to the exact same point in space in those 8 periods.
Yeah.
Why? Because Mars rotates around the Sun, but it does then a spirographic pattern, and the 8th time it doesn't return to exactly the first of the 8 periods. So it's hard to explain with words, but you can just open the Tychosium and see it for yourself. It's there.
The Tychosium is excellent as a visual model, and I shall run some sequences on the video for this to show listeners. The Tychosium shows us that the planets won't all bang into each other. Another sort of obvious sort of question is, if you've got the Sun going around the Earth in the middle, and the Sun going around that, and all these other planets going around, won't the planets all bump into each other? And of course, you can see when you look at the computer simulation, you can see precisely why that doesn't happen. It is quite wonderful.
Yeah.
Sure, it would never happen, because binary systems never crash into each other. Again, all the stars we have around us are binary. They do not crash into each other, but they intersect. Their orbits intersect.
We've touched on the Mars's sidereal alignment issue. Maybe you could include how this so-called retrograde motion of Mars, it's seen to move backwards in the night sky. Can you explain how that ties in with what you were just explaining?
The retrograde motion of Mars, I don't know how many people know about this, but all the planets we have around us periodically stop going forward and appear to go backwards. Mars does this on average 72 days every year. Every 2 years it goes backwards 72 days. But sometimes it goes backwards in less days, and sometimes it goes backwards in more days than 72. It's an average figure. And this irregularity is also unexplained in the Copernicus system, because it's geometrically really a bit dodgy to say that. What the Copernicans say is that because we are going faster than Mars, so when we pass it by, it's like 2 horses on 2 lanes, and so when we pass by Mars, it will look like it goes backwards. But that's not the case. In the Tychos, it actually does go backwards. It might seem strange.
I would just like to say something about the Tychosium and what it shows, and it's been a pleasure and privilege to do this. And one thing I would like to point out is that the Tychosium, to quote Tycho Brahe, he once said that mathematical truth prefers simple terms because the language of truth itself is simple. He liked simple models, and what Tycho Brahe did was extraordinary, because before Tycho Brahe's model there was the Ptolemaic and Aristotelian model, and it was a completely geocentric model where the Earth was situated in the middle, and then we had Mercurius, Venus, Sun, Mars, etc. And and what they did, and the axiom at the day was that planets move in circular orbits at constant speeds. That was axiom at the time, and it's an axiom that makes sense, because if you conduct an experiment with magnetism, the only orbit you can achieve is a circular orbit at constant speed. So it made good sense. But the problem they had was that they could never make orbits of the planet that was circular and travel at constant speed, because we had these retrogrades.
Right.
Sometimes the planets move backwards, and
Yeah.
we can't
So
explain why.
the elliptical orbits was a fudge in order to fit with the observable data. Is that correct?
Yeah, so what they had to do is they had to introduce something to because I mean, you wanted to predict where the planets were at certain points. So what they had to do was to introduce epicycles. That we have a sphere that the planet is hanging on, and the sphere is moving while, so they're rather complicated. But what Tycho Brahe did was that after long studies of observations of the motion of the planets, he devised a system where the sun moves around the Earth while the other planets, just as you mentioned before, while the other planets move around the sun. And the magical thing about that was that this solves the retrogrades. Because if you have this motion, the planets will naturally appear to move backwards from our perspective when they move around the sun in this way.
Yeah.
And this is, of course, exactly what we have done in Tychosium as well. I mean, the axiom in Tychosium is, of course, circular orbits and constant speed. And with these very simple motions, everything is reproduced as we observe it in the sky, including the very strange, irregular motions of Mars, or the what's called empirical sidereal intervals. Mars appears in front of a star, just as you mentioned before, in about 700 days. And then it takes 500 days, and it's in front of, and that is simply unexplainable in a heliocentric model. You can't, and that is also why this is seldom mentioned. This fact, it's an observational fact that Mars does this.
And what about Mercury? Isn't Mercury supposed to accelerate and decelerate in its motion? I mean, that seems a long shot, doesn't it, in order to explain its apparent motion. Can you tell us about that?
Yeah, so I mean, just to conclude, I mean, so what Kepler then did, and that Newton followed up, was to, in order to make a heliocentric system work, you had to step away from the axiom of circular motion and constant speed. Otherwise, it wouldn't work. Right. So what Kepler introduced and Newton followed up was that the axiom that planets move in elliptical orbits at varying speeds, and if you do that, you can have a heliocentric system that's appear where I mean, you have the orbits and the planets slow down and speed up. But I think that assumption, that axiom, it has no basis in physics, because we can't observe anything that orbits in an elliptical orbit and varying speeds. And as you brought up Mercury, and then it becomes really absurd and strange, because Mercury is supposed to accelerate and decelerate, by 34% every 90 days in its orbit. A planet-sized object speeding up and slowing down by 34% every 90 days.
All the time, regularly, year after year after year. It slows down and accelerates by 34%.
Supposedly, yeah. And that would be in space where there's no resistance.
Yeah. But still keeps coming back in regular moments. I mean, it's ridiculous. It's exactly what Kepler just used. The mathematics. He used mathematics, as I like to say,
like it.
Because what he did, he couldn't make the observations of his master Tycho Brahe match. So what did he do? He came up with the idea that the planets accelerated and decelerated, and also had elliptical orbits.
Yeah.
This was the way he could, he stretched and squeezed the things and made them go faster and slower, and that made it all work out. But there's no need for this in the TYCHOS. I have to repeat this, as Patrik just said, all the planets in the TYCHOS system go at the same speed all the time, constant speeds, and go around circular orbits. Perfectly circular orbits, and in spite of this, the Tychosium shows the planets to be exactly where they are observed.
Okay, so if the sun is going around the Earth, and the other planets are going around the sun, so we get this bicycle wheel effect where we see the spiraling and the planets going backwards.
Yes.
So if the sun is moving in a circle around the Earth, but all of the other planets are revolving around it or orbiting it, then necessarily their orbits are wobbling, aren't they? Their orbits are wobbling in space as the sun, being the centre of their orbit. I'm assuming it's the centre of their orbit if they're orbiting around the sun in a circle. If the sun itself is moving, then the centre of their circle of orbit is also moving. So their orbits are moving with the sun, effectively. Am I right?
Yes.
Well,
yeah, that's right.
Yeah,
I mean, that is what makes the retrogrades as well, because when you have this motion and the other one, and you get this strange backward motion of the planets.
So that would imply,
very hard to explain.
Yeah, that would imply that there is some kind of connection, whether it's magnetic, gravitational, or whatever. There is some kind of force that would hold the planets at a constant. It's
just a geometric motion.
Yeah,
it's just a geometric motion, which is now shown by the Tychosium. For God's sake, there's no. I mean, it's so. We have done it. We can show it. The Tychosium works, and yes, they are going backwards because they are doing trochoidal loops. It's called the trochoidal effect in geometry. Mm-hmm. It's just like a bicycle wheel, as you said.
Yeah.
If you put a light on a bicycle wheel, okay?
Yeah.
And you lift the bike. You don't go. You just lift the bike and turn the wheel, and this light on the edge of the wheel will go around in a circle, right? But if you put the bike down and it goes down the road, an observer will see this light doing trochoidal patterns.
Yeah.
Trochoidal patterns, which is exactly what we see Mars doing,
and the other planets too. Do we see all of the planets doing that?
Yeah,
precisely.
I mean,
so the sun is very, very important. The sun is still very important in the Tychos. It's not like I have declassed the sun. The sun is extremely important because it's certainly the strongest part, the strongest magnet of our system.
As you like to point out, Simon, I mean, you usually say that, I mean, the Tychos is a geometrical model. It looks, it finds a plausible geometry for our system and proves it, demonstrates it through Tychosium, that this works. If we assume circular orbit, constant speeds, and we put the planets and the sun in this configuration, it works.
Right.
Okay.
Observably so,
right,
because we have the positions of all the planets in the Tychosium. But of course, what happens with us, we always search for explanations. So we need a physical explanation. I mean, but as you sometimes mention, Simon, it's to make up a physical explanation or a physical model, and then have everything try to fit it.
Yeah.
It's like it's like putting the carriage in front of the horse.
To me, geometry comes
Patrik.
before physics. Geometry comes before physics.
I think it's fascinating that as you say, geometrically, the TYCHOS system, the most important thing to observe here is that it fits with the observable data, and what I'm getting from this conversation is that you guys are not presenting all of the explanation of why. What we've done is you've got a model, a geometric model that reflects precisely the observable data.
Yes.
When we look at the sky, when we measure everything and we put it into a model, we get this tychosium. Now it's our job to now revise all the assumptions we've made previously to try and make the old system work, and now try and rethink things and move our knowledge of reality on as we try to come up with explanations that accommodate this new model. Would that be a fair assessment?
As I say in my book, this TYCHOS does not pretend to be a theory of everything, you know. A TOE, theory of everything. It does not pretend, but it does, go back to the basics, observation. What can we do here on Earth? We cannot, as I am convinced, we have not been able to go out in space and look at. I mean, just ask yourself this question: why hasn't NASA have a satellite right now showing exactly how our system works? Showing there should be a satellite that shows from afar our system exactly how they say it is, with the sun in the middle and everyone going around in a carousel. Well, they don't have that.
To play devil's advocate to that point, you could say, well, everybody is already riding on the coattails of the assumption that we know how the solar system works, so therefore nobody's really calling for an explanation. Nobody is demanding that that NASA prove the heliocentric model, because the whole world is on that assumption already. They're all on board.
Yeah, because we all agree with this,
and they're not looking anywhere else.
We've accepted it. May I now come to an important point, and that is the precession of the equinoxes.
Please.
So that has been one of the biggest mysteries for all astronomers for thousands of years. Why do we see our North Star changing? I mean, we now have Polaris, a star we call Polaris, as our North Star. Well, it's not always been Polaris. 4,000 years ago, or 5,000 years ago, it was Tuban. It was another northern star. The Egyptians have documented this. So there is some motion going on, okay? That motion that makes our northern stars change in time. And astronomers have absolutely established that we go from being under Polaris, then in about 12,000 years we are under Vega, another big star in our sky, and then we go back to Polaris in about 25,000 years. Well, in the TYCHOS, I've calculated it to more precisely 25,344 years. That's what you can see in the TYCHOSIUM simulator. 25,344. What is this cycle? Well, that is the entire solar system. While every body of the system goes around clockwise, as a clockwise motion, it slowly precesses. No, they go anti-clockwise. Why they all go anti-clockwise? All the bodies in our system, the whole system rotates clockwise for some reason, which we have to establish. We have to find out why, but it does go clockwise, and thus dragging Earth around a virtual orbit, if you like. And that orbit, I call it the PVP orbit, because we go from Polaris, from being under Polaris, and then to Vega, and then going back to Polaris. And that orbit, I've been able, as I explain in my book, I've been able to see how wide, what the diameter of this orbit is. And it's about 113.2 million kilometers. I did this calculation many years ago, but years later, when we did the TYCHOS, I found out that Mars, when it comes closest to Earth, it is exactly at 56 million kilometers. 56 million kilometers is half of 113, right?
Mm-hmm.
So Mars is in the TYCHOS system, passing in the middle of this virtual orbit of Earth, which is another confirmation of the beauty of the geometry of our system. So there is nothing in the middle. Earth is in the middle. It's in the barycenter, but it gets dragged over 25,000 years. While this happens around the years, Mars will sometimes pass exactly in the middle. Again, you need to get familiar with the TYCHOS simulator, which shows this. It shows it. It's there. You can touch it with your hands. It's pyrographic motion.
Yeah. Just for people that may not quite understand the astronomy, when we talk of the pole star, of course, we're talking of the Earth's axis of spin. If you take a line straight through its axis and project it straight up through the geometric North Pole, that line at the moment points roughly to Polaris. And you're saying that it isn't. It moves around the sky all the way around to point at Vega, 13,000 years later, and then all the way back. And of course, the conventional explanation is that the Earth wobbles, doesn't it? But I mean, that seems far-fetched.
Right.
It doesn't really seem to work.
That is far-fetched, and it has been disproved by various modern independent researchers that there's no wobble. Because if there were a wobble of Earth, it would affect also our planets. But it only affects the stars.
Yes.
It would affect our planets over time, under shorter periods of time, but it doesn't.
No.
So there's no wobble. The third motion of Earth, which Copernicus had to come up with, because he also knew that the North Star were changes. The North Stars were changing. He had to come up with this third motion of Earth, which is a wobble.
I think it's worth also adding, Simon, if I can interject once again, in that in the TYCHOS model, and again I'll try and run a sequence of this, the Earth's tilt, which of course we all know about the tilt of the Earth as the sun goes around the Earth, or the Earth goes around the sun, gives us our seasonal changes. But this tilt, according to the TYCHOS model, the tilt is always outside of the orbit. So as Earth goes around its PVP, it's always sort of pointing outwards. In that sort of motion. You have to imagine a northern hemisphere tilting outside towards the sun's orbit. Yeah.
Okay, by 23 degrees and a half. So it's always tilted in that way. So I mean, take a basketball in your hand and tilt it towards the sun, and then start turning around, and you will see what I mean.
Yeah. Start
turning around, but the tilt remains the same. The Earth rotates. There is rotation and there is revolution. Two words which we have to always be clear of when we talk about astronomy. So the Earth rotates around its axis every day, every 24 hours, once. That means that if you are at the equator, you are traveling at 1,600 kilometers or 1,000 miles per hour. But, we don't feel that speed, because we are in a pressure chamber with our atmosphere. So it's like we are going in a train carriage. We don't feel that 1,600 kilometer speed of rotation, which I can accept. But what I cannot accept, that we are going at 107,000 kilometers an hour around the sun. That's what they say. We're supposedly moving. Our revolution around the sun would have a speed of 107,000 kilometers an hour. You know what that is? That's 90 times the speed of sound. We are supposedly right now moving at 90 times the speed of sound.
We've covered a lot with the retrograde motion of Mars. We've talked, and we touched on parallax. We didn't discuss it in great depth, but we have also looked at the precession of the equinoxes. But I think the big point that we need to make here, or that I'd like to make, is that this I'm going to call it an alternative model to the mainstream way of looking at our solar system. What it does beautifully is it explains, or it models, the motion of our solar system in a way that explains all of the empirical evidence. When we look to the skies and we look through our telescopes, or astronomers do, all of the things that are seen are explained by this TYCHOS model. And on the contrary, the heliocentric model that we've all been raised with, we've all been told, and we assume is the way it is, with the sun at the center and all the planets going around, that model doesn't actually fit with the observations, and I think that's the big takeaway point, and the fact that we can't necessarily explain why that is, but we can see that it is, and that is a really important first step in science, is that we have to look at the evidence and then come up with a theory of why, rather than coming up with having a theory of why, you know, gravitational and forces and Newton's laws, and trying to fudge what we see to fix it. Seems very back to front.
Exactly. That's it. That's it. We have to start, you know, from the first evidence and the things we can repeat. You know, evidence has to be repeatable.
Yeah.
There are about a dozen things that are still admitted to be mysteries in astronomy.
Yeah.
And those 12 things, I have you know, broached them in my book, and I have given a possible or perfect answer to these mysteries.
In conclusion, for this podcast, did you want to say anything to sort of tie things up, Simon? And also, could you let us know where listeners might get a copy of the book, The TYCHOS, Our Geoaxial Binary System?
Yes, well, I have a website called tychos.info. You can read the basics of my system in the pages that are available to everyone, but you can pay $20 or $25 and read my book on the TYCHOS info website. I've written in this last year 44 other PDFs. I will give you the link to those 44 pages, PDF papers,
okay,
which corroborates the book as well. The Copernican system, as I explain in my book, is geometrically impossible. I've been testing the TYCHOS for every kind of astronomical observations, like, you know, when Venus passes in front of the sun, when Mercury passes in front of the sun, the transits of Mercury and Venus over the years. I've looked at all the tables, I have checked them, and the TYCHOS matches these passages with an extreme high degree of precision.
The basis of science, I mean, the scientific principle is that you have an idea, you have a hypothesis or a theory, and what you need to do then is try to refute your hypothesis or theory. And if you fail to do that, if you cannot figure out experiments or observations that refute it, then it needs to be brought forward and tested by the rest of science. But I think the problem we have here with the current model of the solar system, and I'm afraid we have this problem other
in other spheres of life as well.
Yeah, in other spheres of science and life. Yeah, but
I mean, medical thing.
It's really important in science because that forms the basis of science. And what and I mean what it said that Tycho Brahe said that he said on his deathbed, "May I have not lived in vain." And Simon Shack has made it so that he didn't live in vain, because what Simon Shack has done, and I've helped him with it, but I mean this is Simon's work almost exclusively. I've built some digital instruments for him, so to speak, and followed his research with fascination. But what he has done is he has put forward the hypothesis or theory, or actually model, that Tycho Brahe had, and tried to refute it. We have tested it in every possible way, and we have demonstrated, or we have tested it in a three-dimensional space with programming, and it checks out.
Yeah.
So we welcome science, real science, to pick up on this and continue this work, because that is needed for real science to progress.
Absolutely.
We need to the humanity needs to get its act together
Yes.
on this subject and many other areas, as I mentioned.
Absolutely.
Yeah.
Well, thank you both so much for this. Let's consider this an introduction, and for those people that are interested, we will discuss this topic further, because as you rightly say there, Patrik, we have a crisis in science. The world seems to be dominated by scientism, a new religion, rather than actual scientific method, and facts can readily be discarded if they don't fit a narrative. Anybody who considers themselves a truth seeker will know this. You haven't got to look too deep into anything to see contradictions all over the place. And unfortunately, reason is no longer the standard of thinking and scientific inquiry. So we have got a long way to go. And I really am excited with your work, Simon, because this sort of throws down the gauntlet to other astronomers, to other men of reason, to come forward and, as you say, try to falsify this model. And whilst it doesn't claim to explain how the model works, it does claim that the model fits the observable data. And I think that's a reason enough to be extremely excited about it. And I look forward to talking to you guys more about it. So thank you so much for taking the time to join me today. And I look forward to the next time we discuss this, and let's call it episode 2. And meanwhile, thank you all for listening, and I do urge you to visit the website lawfulrebel.com. There's loads more there on how to find truth and how to take control of your life. And do join us again for another episode of Living Outside the Matrix.